Hello and welcome to Chapter 3, Conditional Execution. In conditional execution we meet the if statement. The if statement is where Python can go one way or another way, and it's the beginning of sort of our way of making Python make decisions for us. Sequential code, we just do some things. Sometimes that's useful, but now we can have our code check something and then make a decision based on that thing. So the conditional steps in Python are pretty straightforward. The keyword that we're going to use is the if statement. And so if is a reserved word. And the if statement has as part of it a question that it asks. And this is asking if x is less than 10. And the colon is the end of the if statement. And then we begin an indented block of text. And the way this works in this particular thing is this line is the conditional line. If the question is true, the line executes, and if the question is false, the line is skipped. And you can think of it the way this is, right? X is 5, ask a question, is it 10 or not? These questions do not harm the value of x. If it is, then we run this code, and then we sort of rejoin here, and then we test this next if, and if that's true, we do this code, and then we do there. But in this case, it's going to be false because x is not less than 20, and so it just continues down here. So if we look at how this works, it runs this line, then it sees this question, it skips that line. So this line does not run, and so smaller prints out and fini prints out. Okay? And so that's the basic idea of an if statement. And the indentation, when we are done with an if statement, we de-indent back, and there's this little block. This is one sort of if statement, and this is another if statement. And these are the two conditional lines that either run or they don't run, depending on the question, the answer to that question. So we have a number of different comparison operators that we can use to ask these true-false questions that say, is this true? So again, we're kind of limited to the keys that were on computer keyboards in 1940s and 1950s, less than or equal to. So we didn't have fancy math characters, so we just concatenated less than and equal to be less than or equal to. This double equals is the asking, is this equal to? And so that's a little tricky. The equal sign is that assignment operator. If I was building a language today from scratch, I would probably make assignment be arrow and the equals question to have an equals. Or I might say, somewhere I would say question equals. But I'm not building this language, so it's not up to me. So this is the question. Double equals is asking the question is equal to. Greater than or equal, greater than, and not equal. So this is the exclamation point is sort of like not equal. So that's sort of not equal. So that's how we do not equal. So if we take a look at some of these in some examples, all of these are going to be true because of the way x is set. If x is equal to 5, that's the question version. That's true or false. It'll execute that. If x is greater than 4, it's going to execute that. If x is greater than or equal to 5, it's going to execute that. Here's kind of a shorthand where if there's only one line in this block, you can kind of pull it up right on the same line after the equals. If x is less than 6, which it is, true, execute that. Then if x is less than or equal to 5, do that. And if x is not equal to 6, do that. Now, like I said, all these questions have been carefully constructed so that they're true, just to kind of show you the syntax of those comparison operators. Now, you don't just have to have a single line of text in the indented block. And this will be something you're going to get used to. So if we indent more than one line, then the conditional code is actually these 3 lines. So the idea is you have an if statement, you come in, you do an indent, and as long as you stay indented, you stay in that if block. If it's false, it just skips all of those. So the way this is going to execute, x is 5. Print before 5 is x equal 5, that's the question mark, and that's true. So it's going to run all these, and then come back, and then continue on in the de-indent, so all this stuff is running, right? And then it says x equals 6, well that was false, so that skips all of them. So none of these lines of code run, so these actually don't run, and it says afterward 6, so that's a mistake. Those don't run right there, okay, because x is not equal 6. Okay? So indentation is an essential part of Python. We use indentation in lots of programming languages, often to kind of demarcate blocks, to to show where blocks start and stop. But in Python, it's syntactically correct. You can make an error if your indentation is wrong. After an if, you must indent. And you maintain the indent as long as you want to be in that same if block. And then when you're done with the if block, you reduce the indent. In this rule of indenting, comment lines and blank lines are completely ignored. So we're going to tend to like put 4 spaces. 4 spaces ends up being the normal thing that we do, and you'll see all the code that I write has 4 spaces for each indent. If I go in twice, I use 8 spaces. And we have this instinct of wanting to hit the tab key to move in 4 spaces. Now the problem is that it might look the same on your screen. A tab and 4 spaces might line up the same place depending on how tabs are set. But Python can get confused by that. So we tend to avoid using actual tabs in files. And so most programming text editors, like if you're using Notepad or Text Wrangler, there's a place to set the tabs to say don't put tabs in this document, but every time you hit a tab, move over 4 spaces. And so you hit a tab, but it's like space, 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 space. Now the nice thing about Atom, and this is the text editor we tend to recommend in this class, because it works on Windows, Linux, and Mac, but also because it automatically sets this up. As soon as you save your file with a .py extension, you can sort of hit the tab key with impunity, and everything works perfectly. But the key thing here is that Python insists that you get this right, and if you don't get this right, you're going to get indentation errors, and they're just another syntax error. So if you're using something like Text Wrangler or Notepad, hunt around in the preferences and you'll find something about expanding tabs, or maybe how many spaces each tab stop is supposed to be. And so you check these, and what this really is doing is telling your text editor never put an actual tab in the document, but somehow simulate tab stops using spaces. And so here is a bit of code. It's got a nested block, but it gives you this sense that you have to be very explicit when you're reading Python code of whether the indent is the same, between 2 lines the same, increased or decreased. And so every time you increase it, you mean something, and every time you decrease it, you mean something, and literally if it stays the same, you mean something as well. And so if we take a look at this, here we have a line, and the next line has the same indent. This is an if with a colon at the end, so we have to increase the indent, and now we're maintaining it. Okay, so these 2 lines are part of that if, but now we have de-indented. So whether you choose to de-indent this word or whatever, where you do this de-indent affects the scope of how far this if statement lasts, right? It lasts up to, but not including, the line that's de-indented to the same level as the if. Okay, so this is a de-indent. Now we have a blank line, which doesn't matter, and we maintain it. And we have a for, which we'll learn about in the next chapter, which is a looping structure. Let's do a for runs this 5 times. It has a colon, and it also expects an indented block. Now we have what's called a nested block, where we have an if and a colon, and we go into some more. So this is like 2 indents, right? So these are 1 indent, and these are 2 indents. And so this is a block within a block. And then we de-indent, so that means this print is not part of the if statement, but is still part of the for statement. And then we de-indent again, and then that means this print is sort of on the same level as that for statement. So if you start thinking about this, you want to be able to start thinking that these blocks are the start of the block with the colon line up to but not including this line that's been de-indented. So the for goes this far, right? The for goes up to but not including the line that's de-indented. The if goes up to but not including the line that's de-indented. So as you do this, you'll sort of mentally start drawing these blocks, and pretty soon you will start constructing them as blocks. And it takes a while, but doesn't take forever. But in Python, unlike other languages, you have this is very important, and it matters, and you can have syntax errors if you get it wrong, because you're really communicating the shape and structure of your code using these indents and de-indents. We already saw a nested indent. This is a nested if, so you can put an if within an if, and you can go as far deep as you want to go, like Russian dolls. And so Here we have x equals 42. If it's 1, we indent 1, and then with this next thing we do, these are at the same level of indent, but now we see an if, and it has to indent further. So this is like 2 in, 8 spaces, and then we de-indent back. Actually, we de-indent back 2. And so if you watch this, and you take a look at how this works, it runs to here. Oops. Back up. Comes in here. The answer is yes, x is greater than 1. Prints this. Is x less than 100? Well, it's 42, so the answer is yes. So it runs this, and then it kind of continues back to there. And you can also think of drawing boxes around this. This is one if box, and then within that if box there is another if box. And again, it's the indent block up to but not including where the de-indent happens. And this here is like 2 backwards de-indents. So it ends 2 blocks. So 2 blocks are ended by where we place this. We could move this in, or we could move this out. We could have it all the way into here, we could have it to here, or here. And where we put that line depends on how the ends of these blocks are going to work out. So one form of that's a 1-branch if that we just saw, but then you can also have what's called a 2-branch if. And the basic idea of a 2-branch if is that you're going to come in, you're going to ask a question, and you're going to go one direction if it's yes, and another direction if it's no. We call this an if then else. It's kind of like a fork in the road. And the way to think about it is, depending on the output of this question, we're going to pick 1 or 2 of these, but if we pick one, the other one's never going to happen. So it's like an either or. We're either going to go one way, or we're going to go the other way, but there is no path where we somehow go boot through both of them. That doesn't happen. And the syntax that we use for this is what we call the if then else. And so the first part is normal if with an indent, and then we de-indent, and then this is another reserved word, else, with a colon, and then we re-indent. And so this is really end up being part of a whole block here, and the else is the part, this is the part that runs if it's false, and this is the part that runs if it's true. The first branch of the if, the first indented block is what runs if it's true, and the second indented block is the one that runs if it's false. And so here we go, just if x is greater than 2, in this case it's yes, we're going to print bigger, and then we're going to be all done. And so we do 1, and so this one did run, and this one did not run. So basically with an if then else, one of the 2 branches is going to run, but there's no case in which both branches run. And again, you sort of draw these blocks around these things mentally, and in this one you sort of take from the if, not the else is really part of the block, up to but not including that print, which is back indented, de-indented back to the same level as the if statement. Okay? This Python is actually one of the more elegant languages, even though after a while this indenting, and when you get too far in, it gets a little bit complex. But this is a good way to visualize this with these indents. Coming up next, we're going to talk about some more complex conditional structures.